I forgot to record this. So we do a summary when we record this. All right. That's also I need to remember to record the video. So what we have, we'll have a force going upwards with a value of 1. Where we got the 1? If you look carefully, we got the 1 from the 1 kilonewtons. So this, I will write a box here. Since I put the units, I don't need to write the units again in the diagram because it will be really messy. I put only shear force, and I make sure that's the units is represented next to it. So it means this diagram is measuring the values in kilonewton. Kind of labeling. We're doing a labeling for the shear force. Now from 1, there is no force till 4. So now you'll ask me a question. Hey, why you didn't include the 2 kilonewtons meters? Because again, the 2 kilonewtons meters is not a force, is a moment. And this is a shear force diagram, it's not a moment diagram. Therefore, I don't need to include this force. So now here is 1, and there is an arrow of 4 kilonewtons going downwards. So it will be 1 minus 4. The answer is minus 3. Therefore, I need to move downwards with a value of 3. So that will be, I'll write it here, the equation. So 1 minus 4 is equal to minus 3. And if you ask why, because the direction of the arrow is telling me how can I find this value. So already at this point, the shear force was equal to 1. Now this 4 kilonewton is pushing it down to 4. Therefore, 1 is positive, minus 4 is because the direction of the arrow going downwards. That will give you minus 3. This is the location of the force. Now, again, nothing happened from this point going towards that end. And because I have support reaction is equal 3, you find that the shear force diagram will be close at that point. And then by this, we have managed to finish the shear force diagram. Very easy, very straightforward. Because I forgot to record from the beginning, so what I will do now, I will just recap and go through and explain everything from 0. So again, thank you guys for attending, because it's really, I know it's Saturday, it's too hard to wake up early morning, but it's good for us to test this software, how it works when we are all from our houses or homes, and we need to test our network, test the software. So we want to see, the question is one of these questions I'm giving you guys in the class. Draw the shear and moment diagrams for the simply supported beam. And you have this question, which 1 kilonewton is going upwards and 3 kilonewtons going upwards is the support reaction. So how do I determine that? Step 1, we always say sketch the free body diagram. And when we sketch the free body diagram, we convert whatever at the hinge. So at the hinge, we have a vertical force and a horizontal force. And at the rolled, we have only a vertical force. We have a moment 2 kilonewtons times meters at 2 meters from the left. And we have a point load 4 kilonewtons about 4 meters from the left, or 2 meters from the right, the way you want to read it. Since there are no horizontal forces in this beam, therefore I canceled the horizontal support reaction, because it's not doing anything for me at this stage. It's possibly can do if we have an inclined force. If this 4 kilonewtons was inclined with an angle, yes, then this force will be trying to make the beam in equilibrium and is not be pushed on the other side. At the moment, the equilibrium is only trying to support in the vertical and preventing it from rotating because of the effect of 2 kilonewtons meters. So to solve that, I took the moment around point B. This is point B, and clockwise is my positive moment. And then what I did, I tried to convert all the forces times the distance and take them to point B. So first one is A, this one, times 6, 2 plus 2 plus 2, 6 meters. And then plus. Now the plus why? Because I have a moment here is 2 kilonewtons times meters. This is, since a moment, I don't need to multiply it by the distance because it's not a force. And positive because I assume clockwise is positive, and it's positive. You can see here the blue arrow is indicating clockwise is rotation, the direction of the rotation. Minus, now I go to the 4 kilonewtons. The distance from 4 kilonewtons to point B is 2 meters. And if you look as well, we say we fix point B, and this will try to push in that direction. So that's 4 kilonewtons counterclockwise. Therefore, I put the -4. Rearranging the equation, the support reaction at A is equal 1 kilonewton. I come here and write 1 kilonewton. Now we need to determine the support reaction at point B. Could be another a question and say, can I take a moment about A and find the answer about point? Yes, you can. Definitely, you can do that, and we can do it now. So we can say or support moments or algebraic summation of moments around, instead of B, we can say A. So if someone doesn't want to take the summation of forces, can do this. It's okay. It's no problem. So what will be if we do that now? So we're taking it about A. So we need to identify which direction are we rotating. So again, I'm assuming clockwise is my positive. So B will be rotating opposite to that direction. So it will be minus B times 6. The 4 will be rotating positive, so plus 4 times 4. And then the 2 kilonewtons now is rotating what? It's still positive, so plus or minus what we be plus 2 equals to 0. So plus plus and minus, and then we rearrange this equation. You will find that B is equal, after simplification, you find B is equal to 3 kilonewtons. So that's the way to show you if you want to calculate it using the moment. So either use this one or use the other one. You don't need to display both of them. So that's why I say or to find the value of B, and we'll give you the same answer. Let's see one of the chats. Must we always assume the moment at point B to be clockwise? No, it's not necessary. That's why I'm saying it. I'm assuming it, to be honest with you, because I find it's very difficult to me to do this arrow, and I'm copying it from somewhere, from other documents. So that's why I'm using it. But I don't know. I always feel clockwise is easy for me to remember the direction of the clock. So that's why I assume it. So if I got confused, oh, which direction? I always remember, oh, the clock is rotating in that direction, so I always using it that way. It's just, how do you feel about it? It's similar to one can write with right hands, the other one can write in left hands, or similar to people knows how to use the mouse on the right hand or using the mouse on the left hand. So it's your preference. It's your really point. Doesn't matter. Now, after we located or found the values for the support reactions, I need to allocate them at 1 kilonewtons, 3 kilonewtons. So I draw my shear force diagram. From 0 point, I'm moving upwards 1 kilonewton. And there is no effect of force along that, because this is a shear force diagram. This is not a bending moment diagram. So that's why I ignored the 2 kilonewtons meters. But definitely the effects of it is calculated in the support reaction. So it doesn't mean I ignore it here. It doesn't include it in the question. No, that's completely it's wrong. No, if you look carefully here, we did add the 2 kilonewtons meters in the support reaction. In both ways we took it. So that's an example. That's an evidence to show you, highlighted in yellow. And now there is a 4 kilonewton pushing down. So this was at 1 kilonewtons. 1 minus 4 is equal minus 3, and then there is no force till I reach to that line, and then I just go and close at 0. So that's the shear force diagram kilonewton. Let's try to do the bending moment diagram and see how interesting, because I'm quite sure here where is the most common confusion about these kind of questions. I just need to fix this. So bending moment diagram is kilonewtons times meters, the units for it. And when I write this again, guys, I don't need to show the units when I write to sketch the values. I just put numbers because I already kind of labeling the figure. So what we learned today, guys, we learned to work by areas, but be careful. I need to write this in different areas. Now you say, why? Why? I have rectangular. And usually in the past, we used to call all of this area 1. All this rectangular, positive area 1. No, it doesn't work. Now I need to have area 1 and then area 2, and I'll explain to you very soon. And the last one, Control C, Control V, area 3. So area 3, I'll put it's negative, if you see. So positive area, and negative area, because this is my 0 line point. So if this was the 1 here, this one will represent for me the 0 reference. So this is the 0 line. So everything under the 0 is negative, above the 0 is positive. All right, let's start calculating the first area, and I'll explain to you why I subdivided that rectangular to 2 areas. In the past, we used to do them only in one area, and then we found it equals. So the first area, it's 1, the height is equal 1, times the length is equal 2, times 2. That will be equal 2 kilonewtons meters. Very easy, very straightforward. So based on what we learned, when it's rectangular, we move with a slope or gradient. It's positive, so I'm moving up. That's what we learned. Because it's positive, I'm moving up. Let's do this in green so we can see the difference. So that's for area 1. In the past, we used to do it. No, we continue till here, to that point, because we consider all of this area. Now I can't do it because I have the 2 kilonewtons meters, which is another moment. So now new things we'll learn in this question, how I deal with a moment existing on my beam in my question. So since I'm assuming everything rotating clockwise, this is very, very important because that's question for the support reaction, then this moment is clockwise. Therefore, the 2 kilonewtons will go up. So from here, we stopped at 2, and then I need to go up with another 2, and I'll put the values very soon. So let's copy this number, make it easy for me. So this value here was 2. Now, the top of that here is 2 plus 2 equals to 4. Let me just adjust it and explain to you what's happened here. 2, I stopped here. Now there is another 2 kilonewtons meters. It's moving up or clockwise. It's going in that direction. Therefore, I will end up adding this 2 plus 2 will be 4. Now, it's not stopped yet. There is A2. I need to determine the value for A2. So A2 is equal to what? If you look carefully to the value for A2, is equal, again, it's 1 times 2 equals to 2 kilonewtons meters. Now, where did comes the 1 and 2? 1 is the height, based on that, and 2 is this distance. So 1 times 2 is 2 kilonewton. But that's not the answer, because I stopped at 4. And this is, here is a rectangular. When I have rectangular, it should go as a slope. Therefore, I need to go and add another 2 to the 6 and going in that direction. So that will be another, I'll color it in green. That will be 4 plus 2. I'll just copy this to show you how it works. To find this point, it's 4 plus 2. So the last area we found, or the moment plus the new area, is equal to 6 kilonewton. So at that point is equal to 6 kilonewtons meters. Don't forget the meters. We're just drawing bending moment diagrams. So here we are at 6. Now, what's the A3? A3, I say it should be in negative. So A3, let's check it. So what do you have? You have the height is 3 times the distance is equal to 2 meters times 2. So that will be equal to 6 kilonewtons meters. And that's where is the most important thing. I stopped here at 6 now I need to go down because it's a negative area. This will take me down to 0. So from that point, I'll go to my 0 point, or the line where is the 0, and then just convert it to green. And this way, I close the bending moment diagram, and that's where it's reading for me the 0. So that's how it looks like, the bending moment diagram, with the effect when you have a moment around this point. So I know it's a very interesting thing to do it in this way. It's a bit different from previous questions we've done, but that's how you deal with it. Now, it's very important question you will ask, hey, why this one is taking you up? Because if you look, when I started solving always this question, I'm assuming clockwise is always my positive, and that's my reference. Clockwise is always giving me positive. Now, if it was negative, if this was going in the opposite direction, what do you reckon will happen? Would take me back to 0, because it will be 2 minus 2, and I will be here. And then I will be going up again with another 2 kilonewtons meters to that point, and then I need to shut down with another, should be like, for example, the support reaction, different values. So if it was the M going counterclockwise, this line should go downwards. The straight line we draw should go downwards. But since it's going clockwise, it's gone upwards. So let us sum this question. What we introduce in this question, it's a very simple application. If you solve it without the moment, will be very straightforward. Shear force without the moment will be the same shape, but not the same values. That's very important, because why not the same values? Because the moment is included in my solutions here. And you can find, I highlight the moments with 2 newtons. I will open you guys for any questions. If you have any questions, you can send me in the privately message. So why is the moment bending moment diagram a straight line going up? Again, because it's clockwise. So because it's clockwise, we'll go up. And that's the good things about it. Since it's clockwise, I assume it's going up. If it was counterclockwise, we'll go down. Guys, if you have any questions, start sending me privately so I will not read your name, I'll just read the question. And in this way, I find if the question is really helpful to answer you guys. I'll give you time to type and to go through it. And if you feel there is anything, just there is another question. Why isn't like a slope? Yes, good question. Always, this is a rule, always when we have moments at a point, we don't take them as a slope. We take them as a straight line. So they don't go vertical. They go on, sorry, they don't go horizontal. They go only vertical. Let me correct this. Only goes vertical, either upwards or downwards. Depends on your assumption. They don't go in the horizontal direction. Moments at a point, always we draw them straight line. We don't take them. So do you remember when we have UDL, we always take them as a slope in the shear force, but when we have a point load, we take it as a vertical. That's exactly the same in the shear force, but now we are in the bending moment diagram. Moments at a point, always we take them vertical, straight line. Any other question, guys? Okay, why the bending moment diagram is in the positive, not in the negative? This is really, really good question. Because if you look carefully, when I sketch the bending moment diagram, it's always related to the areas. I have 2 big areas in the positive direction. So those areas are representing for me as the bending moment is positive. So if I had A1 and A2 downwards, then everything will go down. So areas is the indication where is the bending moment diagram going. That's why we say when I sketch, this is a positive area, this is a negative area. So the negative area, everything trying, see, positive trying to take me up, 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 but the negatives try to bring me down to 0, because this is again is 0 point. Good questions. I like those questions. Is it clear? If it's not clear, just let me know so I can go through it again. So again, the bending moment is positive, looks like that, because those two areas made it to go positive, going up, 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 and then the minus A3 is trying to bring it back to 0. That's a different question. You need to see me maybe later about it. If you have any other questions not related to this one, we can see it. You can see me in the office hours, or just send me an appointment so we can do it. Now I want questions about this example. All right. So I think that will sum up for us for the day. I don't want to take longer from this. I'm just was, as you remember, um, um, so we can sum up this. It's a good question. What I will try, guys, to ask you guys, if I give you the other question actually, which the other one, it's with UDL. So please try the other one with UDL, and then when I see you on Monday class, maybe the first 10, 20 minutes, we go through it. So the UDL question. So you have exactly the same thing, a beam, and there is a UDL, and just at the point B, there is 50 kilonewtons meters of moment, and the other one is going counterclockwise. So that's interesting, because we want to see if it's against the other direction, how it works. So every time we try to explore something, and how can we deal with the moment when there is a UDL, because that's also a very interesting thing. So, and this will end up the session. Thank you very much. I think it's working really good. It's good to see you guys here, because I mean, it's tested yeah, the software with you guys. So definitely, we'll see you on Monday in class, and enjoy it. Take care, guys. See ya.